Hello out there in Machine Shop Math Land. It is April 23rd, 2020. I think this is getting close to the end of the second week of this shifted 6-week session for the Machine Shop Math. This is video number 9. It is the final exam review B. I have 3 versions of that exam. The final and review version B and review version C. We will go through review version B. B as in boy. And that should be suffice to prepare you for the final exam. Again, I'd be working on these exams early. So let's get started. Let's look at the drawing. The first thing we need to do is look at the drawing and see what we have. All right, we have a plate. It's cut off here. It's bobbed. Okay, and all right, we've been given the plate thickness, weight per volume. We've seen this before, so we already know what to do here. 489 pounds a cubic foot. We're going to convert that to 0.0283 pounds a cubic inch. We'll come back and discuss all this stuff that's up here in a minute. We have a coordinate table, so it wants us to give it the coordinates, the x, y coordinates for A through G on this page. So we come back and look at the drawing to make sure that we have a coordinate point. We're starting, A is at 0, 0, and there's X, and here's Y, conventional coordinate system. Let's go to the next page and see what we have over here. Oh, well, looky there. Hole number 1 through 4, the coordinates for X and Y. Now, we've seen this before, and we saw it on exam 3, if I'm not mistaken, in the trig section. And there we go. Hole 1, 2, 3, and 4. 45 degrees. Hole 4 is off of the line for 3. 35 degrees for this line of bearing. These are equally spaced holes this time, and it's 2 inches from 3. 4 is. Okay. All right, it's 2 inches. All right. And hole number 1 is located at X1 and Y5. All right. Well, A is given to us, 0, 0. Point F, or hole 1, is given to us as 1 and 5. If you miss these two, you probably need to quit and go work at Walmart, because that's a give me. Let's go back here and look. Oh, there's point D. That's given to you, 25.375 and 7. So point D is 25.375 and 7. So some of this is already filled out for us. All right. Let's go down and look and see what rest it's asking us for. We've seen this before. It wants the coordinate geometry for the bolt circle, 5, 6, 7, 8, and 9. There's our angular value. We've seen this before. Bolt radius. We have the relative x and the absolute x, the relative y and the absolute y. By now, if you don't know what the difference of those two are, you have not been watching the previous videos and you've not been paying attention. There's not much we can do for you. All right. So, we know what we're expected there. Well, we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So there's 30 points right in here. Plus 2 points up here, so that's 32 points. 1, 2, 3, 4. All right. So, wow, look at that. There's 8 points in here that are essentially a give me. So 32 and 8 is used to be 40 points. So just right in here, between here and here, is 40 points. And go back up to that first page. And we have 1, 2, 3, 4, 5, 6, 7. There's 14 points. So that's 54 points just in this table to be filled in. This table and this table here. 54 points. All right, what's missing? Let's see, we got 4 here. And we want total finished surface area. Total finished surface area. We've worked a problem like that before. Find the total finished volume. We've worked those before. And you know what's coming after the volume is going to be the weight, right? So There's the total finished weight. And then for the drilled holes, they want to know the RPM of the drill. And we've done that. We want to know the total time in minutes to drill the holes with a 125-degree drill point angle. We will walk through that in a minute. So there's 7 here. So 7 plus 54 is 61 total points. So if you just did up to here and got everything right, that would be 54 divided by 61. Well, that's an 88. That would be a B. Actually, it's 88.5, so we would round that to an 89. So you can see by the time you get to this final, we have done all of these in all these previous tests and previous videos. It looks like a lot of work, but if you keep your head about you, it is quite simple, and I'm going to walk you through this. So let's go back to the drawing and get it set up. All right, let's look at the drawing. What do we know based on what we've learned up to this point? Well, we got 0, 0. This is a fraction. We need to convert that to decimal. We're mechanics, we're machinists, we're engineers, so we need a decimal. So 14.25 is the decimal equivalent. 25 3/8 is 25.375. We need that. Now, if you're having difficulty here, we gave you the answer right there. That's D. Merry Christmas. And so you have the coordinates for A, B, C, and D. And you go ahead and put them in the chart right now. Go ahead and put them in the chart. B is at 0 and 1425. C is at 25, 375. That's the X and the Y. Remember, the X comes first, Y comes second. D, if you miss this, you might as well just chuck it in. It's on the drawing. We gave it to you. E, you got to calculate E. We'll get to that in a minute. And F is given to you on the drawing. And G, you have to calculate. Now for E, you already know what the Y value is. It's 0 because E is sitting on the horizontal plane. There is no Y value. It's 0. We've got to calculate this. So let's get started. Let's take a walk around the drawing. Now, this line of bearing of holes is self-evident. We've done that before. That's nothing new. We know we're going to have to get a perimeter distance around this because we want the total surface area. And this has this side, it has that side, there's that side, there's that side, and there's that side. So that's 5 sides around the perimeter. Plus you got a top, and underneath you have a bottom, and the bottom looks like the top. So the perimeter is nothing more than a giant rectangle. If we unfolded all these sides, it would just be one long rectangle that would only be 1.125 inches tall. All right, so let's walk around this thing. Let's go ahead and take care of the bolt circle while we're here. That'll pick us up some points on the bolt circle page. We already got these 2 points because that's where 1 lives, is at 1 and 5, so you can go ahead and fill that in. Back over here, on here and here. You get 2 chances to get it right. See? There's F is 1, and it's the same value there. Isn't that easy? Merry Christmas. All right, so let's look at this circle and put on the data here that we need, that we can transfer to our chart. We have 5 equally spaced holes, and they're 3/4 of an inch in diameter. Now these holes over here are 3/4 of an inch, 750 thousandths in diameter. I made it easy, made all the holes same diameter. And all the holes are through holes. You assume they're through holes unless you're told otherwise. All right, it is a 6-inch bolt circle, so it is a 3-inch radius, a 3-inch bolt radius. Now 5 into 360 degrees is 72 degrees each. If you divide 360, that's the full circle by 5. That means the angular difference between each one of these holes, if you drew an angle from there to there, that would be 72 degrees. That's 72 degrees from there to there, 72 degrees from there to there, and 72 degrees from there to there. You don't have a choice. It's what it is. All right, so 72 degrees. We need to start with the first hole, but how do we get there? None of these holes are located on a major axis. None of them are on 270 or on 0, 360 or 180 or 90. They're skewed. Hole number 8 is dimensioned on this drawing as 40 degrees. 40 degrees from the 270 axis. Now all this stuff in red is not on the drawing. You've got to calculate it. That's why I did it in red. These are things we calculate. So there's 40 degrees from 270. That means hole 8 has an angular value of 230 degrees. Now, from hole 8 to hole 7 is a negative 72 degrees. I say it's negative because we're going backwards to 0. So, 230 minus 72 is 180. That's what I screwed that up, didn't I? That's not 180, it's 158. Here's the hole. Boy, yeah, follow me, huh? Yeah, this is the 180 axis. I'm looking at that and I'm going, there's no way that can be mathematically right. What did you do? All right, so let's start over again. From hole 8 to hole 7 is 72 degrees. You take 230 minus 72, it's 158. Now this is correct. All right. Good night, nurse. All right, so 158 minus 72 is 86, and 86 minus 72 is 14. Now we come back over here to hole 8. See, everybody makes mistakes, man. They get screwed up wrapped around an axle. So hole 8 is at 230. All right, so we're going to add 72 to that. So from 8 to 9 is 302, and that's our last hole. So we have all the holes located angularly with their value. We have a bolt radius. So what we're going to do is we're going to come over here, and we're going to fill in that chart for the bolt circle as best we can. Before we get started doing anything else, go ahead and pick these points up. But one other thing. Now, is there something else on this circle we can pick up? Yes, there is. The center of that circle, G, on the y-axis, the vertical axis, is dimensioned 2 inches from D. Now, D has a value, a y value. D has a y value of 7. X and y, remember? X and y. The y value is 7 plus 2 inches. That gives this a y value of 9 at G. Y value of 9 at G. We haven't figured out our x-axis yet. We got to do that in a minute. So we have the radius. We have the angular coordinates. Just don't do what I did and snap onto that one. And we have the y component for the location of G. So let's go over here to this chart and let's fill this in. Fill in the y for G here. Okay, come over here. So, now where does that go here? It goes right there. So, remember y, the center of the circle is really at 9 on the y-axis. We don't know where it is on x yet, so we go ahead and put your 9 there. All right, put your 9 there. All right. And go ahead and put all the angular values in and double check it. 1486, 158, 230, and 302. Double check it. Double check this. 1486, 158, 230, and 302. Just make sure you double check it. There's nothing wrong with that. You better be double checking stuff as a machinist. I check stuff all the time. Every time I thread and chamber a rifle barrel, I pretend I've never done it before, and I go back to my notes and I check everything off before I start. I mean, you spend $600-700 for a barrel blank. You get one bite at the apple. You screw it up. Well, then it's an expensive tomato steak. I don't garden, so you can't put the stuff back. All right, so here's all your bolt radiuses. So fill them in. So right now you picked up how many points here? You picked up what, 10? Yeah, you have. 10 easy points, plus that one, that's 11. So you're raking up points like crazy. That's good, see? You thought this was going to be hard. All right, now let's go back to our drawing. We've got work to do over there before we can finish. We want to finish up these coordinates in here and then move down the road. Okay, so we know we have this piece here that's cut off. You know this thing started out as a rectangle. It didn't come like this. So we got to figure out what this area is, because we're going to take it away. It reduces the surface area, which will reduce the volume. Now we know all these holes going through this thing are going to increase the surface area from the original. It'll decrease the volume, but increase the surface area. We've already crossed that bridge. All right, so let's get started. We already know that the length of this side is 7.25 inches, right? If this is from 0 to 7 to this point on the Y, and this is at 14.25, this has to be 7.25 inches, right? Can't be anything else. All right, at least not on this planet. Maybe out in outer space or something, we might get some weird stuff, but as long as we're stuck with Newtonian physics, that's 7.25 inches. So let's work this triangle up. Now, this angle started out at 46 degrees, 24 minutes, and 33.55 seconds. Now, you already know how to convert degrees, minutes, and seconds to degrees decimals where you want to be. Divide the seconds by 60 and then add that to the minutes. Then divide the minutes by 60 and then add that to 46. Or you can use a calculator with the magic button on it or whatever. Anyway, your angular value is 46.4093. All right. And that's the angular value. And for that. So let's look and see what we want. We want this leg here. We need this leg to subtract it. We need this dimension to subtract it from that dimension to get that dimension. And then we'll have the x coordinate for E. We already know what the y coordinate is for E, but we need the x. So let's look at this. Which of the holy trinity of trig are we going to use? We got angle, opposite, and adjacent. Angle, opposite, adjacent. Angle, opposite, adjacent. Angle, opposite, adjacent. Now, we know we're going to use some form of tangent. Tangent, right? There's no hypotenuse in there. Now, we've got to figure what the length of the hypotenuse is in a minute, because we got to get the perimeter on that. But let's start with a hard fixed dimension, and 7 is a hard dimension. It's a good dimension because it's on the drawing. Okay? Now, so we're going to use a form of tangent. We're going to solve for the adjacent side using tangent. So that's the opposite side, or 7, divided by the tangent of this angle, 46.4093. Okay? And you do that calculation, and you will get 6.6638. Now go ahead and subtract 6.6638. Double check your calculation. Make sure you got a good number. You didn't screw something up. Do it a couple of times. Make sure that your answer is consistent. Now, take that number, subtract it from 25.375, and you should get 18.7112. Take that coordinate, 18.7112, and go put that puppy right there. Now that one's done. This one was given to you. This one's done. This one's done. That's done. B is done, and A is done. They're given to you right off the drawing. All you got to do is just have your head about you. Now we're going to have to figure out what G is, right? Let's finish this off. Now, now that we know that this is at 18.7112, E is, look at the drawing again. The X value for G is 1 inch negative. 1 inch negative. It's going back to 0 on the x-axis, so it's negative. It's a negative movement. Negative movement of 1 inch. So the x value for G is 17.7112. Not 18, but 17.7112. So you put that down in here. 17.7112. Now we have finished all of this, and you have 14 points, if you did it right. See how easy that is? All right, let's go back to the drawing. We know we need to do some more work on this thing. All right. We're going to need the length of this hypotenuse. Now, You could sit and you could say, well, you know, we could use Pythagorean theorem and I don't have to use trig because trig gives me hives and makes me itch and blah, 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 blah. But guess what? This length was calculated using a trig function. My advice to you, you do what you want. This is America. You have the right to screw yourself up if you want. Lots of people in this country love to do that to themselves. My rule of thumb is if I got a number using a trig function, I'm going to finish the conversation using trig functions. That way we don't run into a problem of a potential. I said a potential mathematical error. In other words, instead of it being 60 degrees, it turns out to be 59.999 degrees. Remember that little episode? Now, does it really matter in the end? I don't know. But as an engineer and as a precision riflesmith, a machinist that really likes precision stuff, I've got to hold a 2.5-inch circle at 1,000 yards with a rifle. So I'm really into precise things. So I'm going to use a trig function, and I'm going to use hard dimensions on the drawing. Use the dimensions that were given to me by the designer. That includes the angle and any dimension like 7. Okay, I think enough. We beat that up enough. So I want the hypotenuse, so I'm going to use a trig function. So I have angle, opposite, and hypotenuse. Angle, opposite, hypotenuse in this conversation. Angle, opposite, hypotenuse. Could use cosine. You're absolutely right. You over in the 4th seat on the 3rd row are absolutely correct. Yeah, you could use a cosine, but I calculated that adjacent leg. That's a calculated number I did. I don't want to do that, remember? I want to use a number that was as fast and hard as we could. Plus, there's no decimals here. So I'm going to use sine. But you're right. You could use cosine. You could. All right. Now, so let's go back and use sine. So we're looking for the hypotenuse. So the hypotenuse is the opposite over the sine of that angle. So it's opposite, which is 7, over the sine of 46.493. And that gives us a hypotenuse of 9.6647. So I'm going to put that dimension right there. Put that dimension right there. Okay, now, we already know that we're going to have to get the perimeter distance around this thing because we're going to have to get the total surface area, and we're going to end up running an end mill around it. They want to know how long it's going to take us to run that end mill. That's time, so time has length. So that means that end mill is going to go all the way around this thing. So we need the perimeter. So while we're here, let's go ahead and add up the lengths of all the sides to get the perimeter. So that's 14.25 plus 375 plus 7.25 plus 9.6647 plus 18.7112, and you should get a perimeter length of 75.2509. Okay? All right. You should get a perimeter length of 75.2509. Now, don't forget your x value for G. We hadn't put that on the chart yet, so we're going to go take this and we're going to dump that where we need to on this chart over here. Right there. We're going to plug that in because that's the adder. That's the x adjustment that we have to give to every one of these relatives that we calculate for x. Remember? This number plus that number gives us that number. And this is our final answer. Now, you've got to get all these right, but all right, so let's go up and work on this bolt circle. Okay. We're going to do this bolt circle, this one here. And then we'll jump over and do that one because this one's a no-brainer. This is easy. An 8-year-old could do that. All right. So we'll go over our notes. Okay, here we go. Final exam review B. This is that triangle expanded. Now, I only did this in one color. Now, I know on the other one, the other video, I did it in multiple colors, but this is a little larger, so I think it'll be okay. Hole number 1, hole number 2, and hole number 3, and hole number 4. Hole 4 is 2 inches, 45, okay? It's 4 inches and 4 inches. All right, so we know where hole number 1 is, right? Hole number 1 is located at 1 and 5. If you don't believe me, go back to your drawing. Off the horizontal axis, it's 35 degrees. So that means this has a bearing, an angular bearing at 35 degrees off the horizontal. Okay? I didn't say it had an angular value. That's a straight line. The angular value of the straight line is 180. Don't get that confused. It has an angular value off of the horizontal plane of 35 degrees. So, work this triangle first, right triangle. Okay? That's cosine of 35. Remember, cosine controls the horizontal. Times 4 inches. This is our relative value for where 2 is. Plus, where did 2 actually start from? 2 actually started its life at an x of 1. So, an x of 1. So, we're going to take cosine of 35 times 4 plus 1, and we get this value here, 4.2766. Now, figure out your y for 2. Sine of 35 times 4. Remember, sine controls the vertical in this kind of relationship. Plus, where did it start its life at in the y direction? It started at 5. So sine of 35 times 4. This is your relative position. Now you're going to make an absolute position. Add where it started at a y of 5. And guess what? There's your answer there. You take these two answers. You go put them back up in this chart. Up here. There and there. I'm going to work on 3. X of 3 and y of 3 is the same thing. Cosine of 35 times 8 this time. So it's from 1 to 3 is 8 inches. That's where the length of the hypotenuse is. All right, so 1 to 3. All right, so cosine of 35 times 8 plus 1, because 3 started its life at the same x location that 1 did. It is 7.5532. Y of 3, sine of 35 times 8 plus 5 equals 9.5886. You're going to take those two numbers, x and y, and keep them in the proper order and put them right there. There's your x value for 3 and your y value for 3. Nothing breaks my heart more and makes me want to cry and kick my wife's cat around than your students getting the right number but switching them in the columns, because I won't give you credit. If you think that's your x value and you get that switched around, no, I'm not going to give you credit because you didn't get it right. If you told a CNC machine you got your number switched and you're programming on your CNC machine, you're going to blow the machine up. You'll crash it. So, just because you played on the soccer team doesn't mean you get a trophy unless you win. Okay, you crash the machine, you don't win. So, if that gives you heartburn, then go do something else. I don't know, go sell flowers or something. All right, let's go work on 4. All right, so we've got these values for 2 and 3. Now we're going to get the value for 4. So let's look at our story. All right, 4 is on a line of bearing from 3, 2 inches long, 45 degrees off of 3's axis through 1. So that's 45. So we raise the horizontal plane up so that we have a line through 4. It intersects this line here that 3 is located on. 35 degrees, same angle. If you'd have read all your angle laws on the formula sheet and in the book references, you know that those are angles. That this angle is 35, that's 35. If we did another line, that would be 35. So 35 minus 90 gives you 55 degrees. 35 and 55 is 90. 90 and 90 is 180, and the sum of that triangle has to be 180, right? Okay, so we know that angle is 55. The only reason we care about that angle is because we're going to need it to find that angle. We need that angle to find that angle. So 45 and 55 is 100 degrees. That straight line is 180 degrees. 100 degrees minus 180 degrees leaves you 80 degrees. 45 and 55 is 100 degrees. Subtract that from 180. That's a straight line value, right? You end up with 80 degrees. Now, we've worked this twice now, this kind of problem. So I didn't put all the steps down here. You should be able to figure that out on your own now. Replay the video. So if that's 80, 80 minus 90 is 10. And remember, we want to use this angle here. That way, cosine still controls the horizontal, and sine still controls the vertical. Cosine still controls the horizontal. Sine still controls the vertical. So we're going to use this angle here. Make it easy on ourselves. Now, the only difference is is x is positive. 4 is moving in the positive direction on the x-axis. It's getting larger. It's moving away from where 3 is at on the x. It is not doing the same thing in the y. The y is negative. It's below 3, so it's moving in a negative y direction. From 3 to here is going back towards 0. That's negative, negative, negative. So we're going to come down here and set it up. Cosine of 10 times 2. This is our relative position. When we add the x value, the real absolute x value for 3, which was this right here, this is this number here, isn't it? Isn't that number and that number the same? That was our absolute x value for 3. It goes here. So cosine 10 times 2 plus that number gives us our real absolute x for 4. Now remember, this is a negative, so it's negative sign. Now you don't have to put a negative in front of the sign function on your calculator. Just remember to turn this number here negative. So all you need to do is make sure it's negative. Make sure you're subtracting it. Okay? All right. So sine of 10 times 2 gives you your relative position, and it's negative. It's negative. It's going to take away, not add to this. So we take this negative number, and we're going to add it to the y of 3, 9.5886, and we end up with the absolute y value for 4. And it's 9.241303645. We take all of this before we forget and go back up to this chart. And go back up to this chart and plug that in before we forget. Now you've just gotten another 8 points, right? Okay. Now we've already got this filled in from our drawing. We've got our bolt radiuses filled in from our drawing. That's assuming you're doing it the way I'm telling you to do it. And you got a right to do what you want. You send me some garbage, and I don't have any mercy on your soul. All right. There's our adder. That's the center of the circle on the x. That's the center of the circle on the y plane. Now the rest of it is just plugging it in. It's the cosine of that angle times that bolt radius gives you that. You add that to that, and you get that. Again, for bolt hole number 6, you take the cosine of that angle, multiply it times that bolt radius, and you get that number in x land, and you add that to that, and you get that. 158, cosine of 158 times the bolt radius of 3, you'll get a negative number, this. You add that negative number to that positive number, and you will get that number. That is your absolute x for 7. Again, cosine of 230 degrees, which is the angular value for 8, and times the bolt radius of 3, you get that number. It is negative. You add that to your relative to your adder, your x adjustment, and you will get that number. For number 9, take the cosine of this angle, the angular value for hole 9, times the bolt radius. You get this number here. You'll add that number to there. To that, and you will come up with that number there. Now you're done with your x's. Let's go over and do the y values. Now if you want to do them across, that's fine. All right. Sine, you'll take the sine of 14 degrees times 3, and you'll get this number. You'll add that number to your adjustment, which is 9, and you get that. You'll take the sine of 86 degrees times 3. You'll get this number. You'll add that to 9, which is your adjustment, and you'll get that. You'll take this angle, angular value, multiply that times the bolt radius of 3. You'll end up with that number. And you'll take that number, you'll add that to your adjustment for your y. Remember, that's the center of G in the y land. All right, and you'll get this number here. You'll take the angular value for hole 8, which is 230, times the bolt radius of 3. You'll take the sine of 230 times the bolt radius of 3, and you'll end up with that negative number there. You'll add that negative number to 9, and you'll end up with your absolute y, in that case, for 8. And then finally, for 9, you'll take the sine of 302 degrees times 3 inches. You'll get this negative number here. You'll take that negative number, you'll add it to your 9 adjustment, and you'll get that number there. Now you are done, and you have picked up all these points. Easy peasy. Just as easy as it can be. Oh my God, I can't make this any harder. Dude, I try. I'd like to, but it'd make me, I just can't. This is just as easy as it gets. So, if you've done everything up to this point, you made an 88. See how easy that was? And I've only been yapping for 35 minutes. So, all right. I think exam 3 has actually got more moving parts in it than the final does. All right, so now let's look. We want the total finished surface area. And from that, we want the total finished volume. We want the total finished weight. And then we'll get back over here to the RPM stuff. Oh, you could do the RPM stuff now on this page if you wanted, before you go over your note pages, because it's 90 surface feet per minute. The feed rate, is coming next for something else. So for right now, it's 12C divided by pi d. You know that the diameter of the drill is of the hole is 3/4 of an inch, 0.75. So while we're here, let's go ahead and knock the RPM out. So that's 12 times 90 divided by pi divided by 3/4, 0.750. And that ends up giving us 458.3662 RPM. All right. Okay. Now let's go over and get these. Pick up these other points. This is too easy of an exam to leave points on the table. And you're going to want to know the total time in minutes to drill the hole. You're going to have to adjust for that, and we'll get to all that in a little bit. That's kind of like the icing on the cake. All right, total finished surface area. This is all the space it took me to do that. Okay, it's not like you've got to run up a big encyclopedia of pages. And we know that whole block at 14.25 by 25 and 3/8, 0.375, came in as a giant rectangle. And we're going to subtract this triangle out of it. We're going to subtract what the holes, the bolt holes. So let's start out with the rectangle, just like we got it from the steel shop. 14.25 times 25.375, that equals 361.5938 square inches. Now that's before we do anything to it. Excuse me. Less the surface area from the triangle. And we know the area of a triangle is 1/2 the base times the height. So that's 1/2 times 6.6638 times 7. That was the base we calculated, and that was the height we were given. So that's a negative. It's negative space, remember? Remember the donut hole thing? I think I'd have issues with donut holes, huh? A negative 23.3233 square inches. Now, just in the two-dimensional plane, just in the plane that you see on the drawing, we're going to take the surface area of what all those holes represent. Now, that's not the volume yet. We'll take care of the volume later. That's just the surface area. Okay, so we're less the surface area of the 9 holes. So, what's the area of a circle? It's pi d squared over 4, and there's 9 of those, times 9. So that's pi times 0.750 squared divided by 4 times 9, and that gives us a negative 3.9761. That's all 9 holes. So the surface area, just of what you see on the drawing, just the top, is 334.2944 inches squared. Now I'm going to move that over here to a column. That's the surface area of the top. If you do it like I'm doing it, you won't screw this up. Equals 334.2944 inches squared. Okay, that's the surface area of the top, just as what you're looking at on the drawing. It's 2 dimensions. Now, we know that this thing is uniformly 1.125 inches thick, yes? Now's the time to do your volume. Before you do anything else, go ahead and stop and fix the volume. You do that by multiplying it times the third dimension, 1.125. So your volume is 376.0812. 376.0812. 376.0812. 376.0812. Inches cubed. Inches cubed. Remember, that's not in there, it's wrong. So you take your surface area of the top times the thickness, and this is what you get. Now take this number and go fill in the chart. Fill in your answer sheet so you don't forget. There it is. It's my test. I did it. I got lost. All right. So here's the volume. So go ahead and put that number right there. Now you want the weight. So while you're here, before you even go finish the rest of this, while you're here, multiply it times 0.283 pounds per inch cubed. And you'll have your finished weight. Right? Now those two were done. That one's done. Now you're going to go back and work on this, total finished surface area. See how easy this is? Pretend you're a machinist. Be smart about all of this. All right. Let's go back to our surface area. All right, so we got our volume. We did our weight over there on the answer sheet. Okay. So if the surface area of the top is this, then that's the surface area of the bottom, right? Of course it is. The top and the bottom are the same. Now we need the surface area of the perimeter. We already know what the length of the perimeter is because we calculated that. It's 75.2509. We wrote it on a drawing so we wouldn't forget. Now, all the perimeter is the giant rectangle. We unstrip the ribbons. This is a cardboard box, and we cut the side off. We had this side and that side and that side and that side and that side. And it's all the same height, right? It's 1.125. So the length, the perimeter, it's one dimension, times the height, which is the second dimension. That gives us area, square inches. Multiply those two together, and you get 84.6572625. Now, these are additive. These are not negative numbers. They're additive numbers. We took care of the negative stuff over here. All right. So it's 84.6573 inches squared. Now, the surface area of the interior of the hole. So some people get screwed up on this. You shouldn't. We've already done surface area with a hole in a previous test. Previous review of the video, I think it was for exam 2 even, worked through one of these. All the surface area of the interior hole is a circumference times how long the hole is, how deep the hole is. So those little individual circumferences stacked on top of one another. And in this case, we have 1.125 inches of circumferences stacked on top of each hole, right? So the circumference of a hole, the distance around the hole, is pi d. Now that's just in inches. It's not inches squared. It's just linear measurement. So we've got them stacked on top of one another. We got 1.125. So now that's the second dimension. So now we get our area of square inches. So pi times the diameter, which is 0.750, times 1.125 gives us the surface area of the inside of one hole. We got 9 of those times 9. So our total surface area of our holes inside the holes is 23.8565 inches squared. Add this up. You add the 23.8565 to the 84.6573 plus the 334.2944 plus another 334.2944, and you get a total of 777.1026 inches squared. You take that number and you plug it back in. Plug it in right there. And now you got all the right answers on this page. My goodness, y'all are going to make an A on the final. My. All right. Now let's go finish this off. We want to know what the total time in minutes to drill the holes if the drill's a 125-degree drill point angle. Now, you're not going to fall with these Jedi mind tricks. You already know what that means. We're going to have to add the Z depth, right? Yeah, you're already smart now. You've already graduated from Jedi school. All right, so here we go. So we know we need a length. We know those holes are going to be added to with the Z depth, right? So the first thing we got to do is do the do the length. We start off with 1.125, and then we got to add the Z depth. So what is our Z adder? Well, it's 0.5. It's half the diameter, which is 0.750, divided by half the drill point angle. So what is half of 125? It's 62.5 degrees. So you take 0.5 times 0.750. You divide that by the tangent of 62.5 degrees, and you end up with 0.1952 inches. You take the 0.1952 inches, you add it to the thickness of the plate, 1.125, and you get the total length of one hole of 1.3202. Now, you remember from the previous video when I derived that equation for y'all, and I gave you that this equation's in your master formula sheet. You need to write that down so you don't forget it for the rest of your life as a machinist. You're going to, in the real world, you're going to add some distance to this to clear the hole and the dwell time and all that other stuff. But that's real machining. This is just machine shop math. There's 9 of those. So 1.3202 times 9 is 11.8818. Now, again, that's your length. You've done calculated it. Throw that in there. You calculated the spindle speed of that drill from the previous page. You did that before you even went over on the second page, on the other page. So you're going to divide that by your spindle speed and divide that by the feed rate, and you end up with 1.7281 minutes. You're going to take that, you're going to plug it in the answer, right? Now, some people forget, they overlook that this is an actual question up here, because I guess it's too close to the header. Don't forget number 5. Don't forget 5. Yeah. Your final will have 3 pages. There's 4 for this review because I have that scratch sheet. When you submit that thing back to me, I better see your work, or I'm not going to give you credit. All right, now, using a 3/4 inch for flute end mill, a cutting speed of 450 surface feet per minute, and a feed rate of 0.008 IPR, what is the spindle speed? Well, I gave you the formula again. You'll use this formula. You won't use Billy Bob's shortcut formula. You're going to use this one. So that's 12 times 450 divided by pi divided by the diameter of the end mill. And you end up with 2,291.8312 RPM. And it wants to know the total time in minutes to mill the perimeter of the part. That was the hint. Even the FBI would have stumbled over that and caught it. There's your perimeter. You already calculated that, and you've used it several times now. All right. So 75.2509 divided by the feed rate, which we gave you up here, of 0.008, divided by your RPMs, which you calculated. So assuming you did all this correctly, and you drive that calculator soberly, then you should get 4.1043 minutes as your total time to mill the perimeter of that part. And that concludes your final exam. This is just a different. Now remember, again, these answers are not the answers for the final. You've got to calculate all that because it's the different parameters on the final exam. Same drawing, same stuff you got to do, but it's going to be different dimensions. All right? So, all right, that's it. We're at 48 minutes. Okay. Well, good luck. If you got any questions, send me an email. All right, bye-bye. Happy mathing. Happy machining. In fact, I'm going to go out in the shop and work on a rifle.